Have you ever gazed at the night sky and wondered what it would be like to travel to another star system? The concept of interstellar travel, journeying beyond our solar system to explore distant stars, has long captivated the minds of scientists and dreamers alike. Yet the vastness of space is a humbling reminder of the immense challenge such a voyage would entail. Take Alpha Centauri, our nearest stellar neighbor. It lies some 4.37 light-years away. In layman's terms, if you could travel at the speed of light, it would still take you over 4 years to get there. Now consider our current technology, conventional chemical rockets. To reach Alpha Centauri using these would take tens of thousands of years, an unfathomable timescale that far exceeds a human lifetime. The reality is, our current technologies are woefully inadequate for the task. So the question remains, how do we traverse these cosmic distances? One cannot simply walk into Mordor, and certainly not into another star system. We need a new kind of propulsion. And indeed we do. Our current propulsion technologies, the chemical rockets, are about as useful for interstellar travel as a bicycle would be for a cross-country road trip. They simply can't get us there fast enough. Enter advanced propulsion concepts, where science is pushing the boundaries of what we once thought impossible. We're talking about nuclear propulsion, using atomic reactions to create thrust. Ion propulsion, where charged particles are expelled to propel spacecraft forward. And then there's the Breakthrough Starshot initiative, an audacious plan to use powerful lasers to send tiny spacecraft to nearby stars at significant fractions of the speed of light. As our spacecraft approach these immense speeds, they encounter the mind-bending world of relativistic effects. Time on board starts to move more slowly compared to time on Earth, a phenomenon known as time dilation. Advanced propulsion could allow us to reach the stars, but what about the journey itself? Imagine embarking on a journey where multiple generations of humans will live and die before reaching the destination. This is the idea behind generation ships, a concept that proposes sending large, self-contained vessels on long interstellar voyages. These ships wouldn't just be vessels, they'd be self-sustaining ecosystems, mini-worlds in their own right. They'd have to support human life for potentially hundreds of years, with each generation passing on the torch to the next. But could we start smaller, perhaps with unmanned probes? Probes could carry scientific instruments, gathering data, and transmitting it back to Earth, paving the way for future human expeditions. Selecting our destinations is a fascinating challenge. We'd need to study nearby stars, identify potentially habitable exoplanets, and weigh the pros and cons of each. Our target would need to be within our reach, but also worth the immense time and effort. Choosing our destination is crucial, but what about the risks we might encounter along the way? The space between the stars is not as empty as one might think. It's a cosmic sea, teeming with invisible particles, cosmic radiation, and occasional dust and gas. It's not a serene sail, but a voyage through a stormy ocean where cosmic radiation poses a significant hazard. To venture safely into this sea, we need to develop advanced shields, technology that can protect both the spacecraft and the passengers within. But beyond the physical challenges, there are ethical and social considerations to ponder. What about the generations born and raised in the confines of a spaceship, isolated from Earth and the life we know? How will governance and decision-making work in such an environment? These questions require just as much attention as the scientific and technological hurdles. Interstellar travel is a distant dream, a challenge that pushes the boundaries of our knowledge and technology. But isn't that what makes it so fascinating?